circles. We have another problem that involves some insight about circles. 20 distinct points are marked on a circle and labeled 1 through 20 in clockwise order. A line segment is drawn between every pair of points whose labels differ by a prime number. Find the number of triangles formed whose vertices are among the original 20 points. So for this kind of problem, why not just draw the 20 points? Well, actually, we're just going to list the prime numbers. So what are prime numbers? 2, 3, 5, 6, 7, 11, 13, 17, 19. These are all the prime numbers. Sorry, I'm just going to rewrite that. It looks kind of funny. So now, for this problem, we kind of have to do some casework. Now let's say, if a triangle is formed by connecting by the 3 endpoints, we call it A, B, C. Then we want all of these to satisfy. So first, the absolute value of A minus B. Yeah, let's just call this PB this such set. Then first we want the absolute value of A minus B to be in P. So all of these must satisfy in order for such thing to be valid. So now, can 3 numbers all have a difference of 2? No, it's not. So we must have 2 numbers to have a difference of odd, right? At least one pair. So let's say if all 3 pairs have a difference of an odd number, then keep in mind that if you want 2 numbers to have an odd difference, then what's going to happen? Then if they have an odd difference, then we must have one to be an even and one to be an odd. Without loss of generality, we're just going to let the first 2 be odd and even. And now, what if we want these 2 numbers to have a difference of an odd number? Then this one must also be even. But now we have a contradiction here because even minus even is also an even. So it's impossible for all 3 to be an odd. This works the same if we just switch these 3 spots to OE and O, since 2k plus 1 plus 2f plus 1 minus is an even number. So therefore, this is easy to prove that we must have one of them to have a difference of 2 for all of the pairs. So therefore, this basically means we either have 2 odd and the even, or let's see if it's possible, 2 even and the odd. So these are the only 2 cases. So let's say if the first number is x and the second number as x plus 2. Then what is this third number? Then let's say this third number is equal to k. Alright. Then for these 2 differences to both be prime, well, think about that. We must need 2 prime numbers to have a difference of 2. Now look at spectate these two parts, we can either find this group to be satisfying, this group to be satisfying, or if this group to be satisfying. So we're going to just casework through all of these. So first, let's say if, so for the first case, then this will be x plus 7. So now, keep in mind, all of these must be between 1 and 20. So x plus 7 can have a maximum of max of 20. Now, what is the minimum of x? Minimum of x is 1. So this gives us 1, 3, and 8. So basically the minimum is going to be equal to 1 plus 7, which is 8. This is actually case number 1. So therefore, for this one to be satisfying, we must have 20 minus 8 plus 1 is equal to 13. Such cases. So now, what about for these two cases? So for these two cases, but this one just basically changes to x plus 11. To x plus 11. So we change this to x plus 11, then how many cases do we have? So if we have x plus 11, then the maximum is going to be 20. No, this is actually 13. So we have a maximum of 20. But the minimum value of x is what? Is 1. So minimum of 14. Yeah, so this gives us 7 cases. Now we also want to consider when the cases 3 and 5. So this will have x. So this will also have x plus 2, and we also have x plus 7. No, x plus 5. Yeah, x plus 5. So this will actually give from 0 to 15. No, 1 to 15, so there's 16 possibilities. Now 17 and 19, we actually have clearly no possibility. So, but 36 is not our answer here because we have to consider some other cases. For example, like yeah, so basically for this case we can also have, what if this is in front, like x minus 3, then this can also work technically. So this will actually indeed produce a new order pair of 1, 4, and 1, 4, and 6. But this one's actually not included in our case that we have been counted. We only counted 1, 3, and 6. So therefore, we actually have 13 plus 7 plus 16, but we're multiplied by 2. Since the last element, you have 2 elements that are different by 2. But the last element can actually be both in front and also in back. So like here, right? You can have x plus 5. That is after this. But you can also have before this. And this can actually produce the same number of such variations. So therefore, we add these three numbers, but we want to multiply by 2. And this actually gives us an answer of 72, which is indeed our final answer. Thank you for watching, hope you enjoy, and I will see you in the next video.